Alrighty, we're going to continue graphing equations using a table. And so when I say graphing equations using a table, what I mean by that is that we're given an equation that they want us to graph on this coordinate plane. And we're going to use this table here to help us do that. And so what we're going to do is we're going to pick 5 domain values or 5 x values to plug in for x. We always want there to be 2 negatives, 2 positives, and 1 0 value. So I'm going to put 0 here in the middle. If there is no fraction with x, I always just use -2, -1, 0, 1, and 2. So in this case, I'm going to use those 5 points for x. And then we've got our equation 2x minus 6. So 2 times x in this case is -2 minus 6. The next one is 2 times -1 minus 6. 2 times 0 minus 6. 2 times 1 minus 6. And 2 times 2 minus 6. So when I get my y values, I have to use order of operations. 2 times -2 is -4. And -4 minus 6, we're going to have to use copy, change. Now that I have two numbers that have the same sign, I add and keep. So -4 plus -6 is -10. 2 times -1, a negative times positive is a negative, so I've got -2 minus 6. Again, I'm going to have to use my copy, change integer rules to change adding a -6. And I've got -2 plus -6, signs are the same, so I add 2 and 6 and keep my sign, which is -8. 2 times 0 is 0, and then 0 minus 6, again, if I copy, change, I add the opposite. And I have 0 plus -6, which is just -6. Then I've got 2 times 1 is 2. Again, I'm going to always use order of operations. And 2 minus 6, I have to copy, change. Now this time signs are different. 2 plus -6. And so I subtract. 6 minus 2 is 4. And keep the sign of the higher number, or the number with the greater absolute value, which is negative. So I have -4. And then this last one, 2 times 2 is 4 minus 6. Copy, change says that I add the opposite. When signs are different, we subtract. 6 minus 4 is 2. Keep the sign of the higher number, or the number with the greater absolute value. In this case, that's negative. So I keep the negative with the 2. And now I'm going to write all of these points as ordered pairs. So when I plugged in -2 for x, y was -10. When I plugged in -1, y was -8. When I plugged in 0, y was -6. When I plugged in 1, y was -4. And when I plugged in 2, y was -2. So now I'm going to graph these points. -2, -10. -1, -8. 0, -6. 1, -4. And 2, -2. Once I plot the points on my graph, I can use a straight edge ruler or even just a blank sheet of paper to help me draw my line and connect my points. Remember that I'm not going to stop with my points right here. I want to go all the way through the graph from one side to the other. Once I do that, I can draw my arrows on my line. I can label my points, so -2, -10, -8, -1, -6, 0, 1, -4, and 2, -2. And then I can label my number line here, or my equation line here, with the actual equation y equals 2x minus 6. And then linear or nonlinear, because all the points fall in a straight line, we consider this graph linear. And we'll talk more about that in the next couple days. So at this point in time, I want you to go ahead and describe any patterns you notice, and how is this different from the graph in example 1. So what's different in this graph than this graph? I just want you to jot a note to yourself. So please actually do this. Actually jot a note. Even though I'm not going to write a note, I want you to write a note so that tomorrow at table time we can talk about these things and talk about the patterns that we notice, and the differences from example 1. So this is example 2. I want you to compare it to example 1, and I want you to talk about any patterns that you see and then anything that's the same or different from one graph to the next. And just jot that here so that you have notes to talk about tomorrow in class.